my dear students. We are back for another session of Mathematics 10 with me, your teacher, Mr. Pineda. Today, you will learn more about the arithmetic means. Arithmetic means. Obviously, we have to start with the definition of arithmetic means. So the arithmetic means are the terms between any two non-consecutive terms in an arithmetic sequence. So let's say that we are given with the arithmetic sequence a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. The arithmetic means between a sub 1 and a sub 5 are those terms found between them. And those are the a sub 2, the a sub 3, and the a sub 4. To further understand the concept of the arithmetic means, let us have another set of examples. So here, we need to identify the arithmetic means between the indicated terms of the sequence. And here is our question. What are the arithmetic means between negative 6 and 26 in the sequence negative 6, 2, 10, 18, and 26? Here, we have to locate both the negative 6 and the 26 in the sequence, and here are those. Now, all the terms found between them are the arithmetic means, and those are 2, 10, and 18. Now, let us proceed with the next question. So, the next question, what are the arithmetic means between 9 and negative 3 in the sequence 9, 5, 1, negative 3, and negative 7? So again, we need to locate both the 9 and the negative 3 in the sequence, and here are those. So now we only have two arithmetic means between them, and those are the 5 and the positive 1. And let us proceed with the third example. What are the arithmetic means between the negative 19 and the negative 7? So again, locating both the negative 19 and negative 7 in the sequence, we have those here. And there is only one arithmetic mean found between the two, and that is the negative 13. Now, let us proceed with the problems involving arithmetic means. And for our first problem, find 8 arithmetic means between 5 and 68. So the information that we have so far in this question are those 5 and 68. But we need to insert 8 arithmetic means between them. So let us try to illustrate the problem this way. Writing the 5 first, and then we have to provide 8 blank spaces for the 8 arithmetic means, counting 1, 2, 3, 4, 5, 6, 7, and 8. Now we have our other given 68 here. And that brings the total of 10 terms. So remember, we have 2 given terms, and we have 8 arithmetic means between them. So far, the only information that we have for this is that we could make an assumption that the 5 is our first term, writing a sub 1, and our 68 being our 10th term, denoted as a sub 10. And we have also learned in the previous lesson that we can come up with any particular term in the sequence using the n formula for the arithmetic sequence, which is the a sub n equals a sub 1 plus the quantity of n minus 1 times the common difference t. If we try to run a data sufficiency test for this using all the information provided in our problem, then we may assume one particular term for our a sub n, and that would be our a sub n, for which we will have a value that replaces the a sub n in our formula. Knowing that we have our a sub 10, for which the n right here corresponds with the 10, then there will also be a value that replaces the n in our formula. While the a sub 1, obviously, is given to be 5. And now, if we take a look at this formula, we are only left with one unknown value, which happens to be the common difference. So that means we can make use of this same formula for us to find the value of the common difference. But how we will be able to make use of such information about the common difference for us to know the arithmetic means in the problem? Obviously, by using the definition of the arithmetic sequence that you have learned in our previous lesson. Again, what is the arithmetic sequence? An arithmetic sequence is said to be a sequence for which each new term after the first term is defined by adding a constant number to the preceding term. And that's what we will be doing here. Once we have the value of the common difference, we will be adding such value to 5 so that we get the second value. And using the second value being added to the common difference, that gives us the third value. So by merely repeating that same procedure, that reveals all the arithmetic means in this problem. And that's it. So let us try to solve for the value of the common difference in the problem. So having the a sub and the a sub 10, and let us try to substitute directly the value of a sub 10, which happens to be 68. And for our a sub 1, we have 5. Since your n corresponds to 10, so this n changes to 10, and we will have this equation. Now, we should manipulate the resulting equation further by simplifying this, 10 minus 1, and that gives us a 9. Doing so, we have this equation. And now, to further manipulate this equation, we must apply the addition property of equality. So the addition property of equality simply states that the number that we have added to one side of the equal sign should also be added to the other side of the equal sign. In this equation, our goal is to transfer the 5 to the other side. By doing that, we must add the additive inverse of 5 to both sides of the equal sign. Additive inverse means the opposite of the integer. In this case, the opposite of 5 is negative 5. So adding the negative 5 to both sides of the equal sign now gives us 63 equals, so since that 5 plus negative 5 gives us a 0, we will not be writing the 0 anymore on the right hand side of the equal sign, giving us only 9b. And now, here, we must apply the multiplication property of equality so that we can eliminate the 9 or the numerical coefficient of our common difference p. Now, what does the multiplication property of equality states that what we have multiplied to one side of the equal sign must also be multiplied to the other side of the equal sign. So let's say, for example, using that exact equation here, 63 equals 90. Our goal is to isolate the common difference d by eliminating the 9. So with that purpose, we must multiply the multiplicative inverse of 9, which happens to be its reciprocal. So remember that the reciprocal of 9 is 1 over 9. Okay? And multiplying a number with its reciprocal always gives us a 1. And let us see. So 9 multiplied with 1 gives us 9. And now dividing the 9 by 9 gives us a 1. So that means if we multiply this to 1 over 9, the same with the right hand side of the equal sign, gives us a 7, while here it gives us D. Okay? So now let us do that same procedure here. So applying the MPE requires us to multiply both sides of the equal sign with 1 over 9. So here we multiply the 63 with 1, divide it by 9, and it gives us 7. While here we have our 9 multiplied with 1, that gives us 9, divided by 9 gives us 1. And 1 times D gives us the value of D. And this will be the common difference of this problem. So let me just erase all this first before we proceed. And like what I have said before we have started this computations, we may now use the value of the common difference so that we have the second term in the sequence. And that is by adding the common difference of 7 to the first term, 5. So 5 plus 7 gives us 12. And then to reveal the third number, we must add the common difference of 7 with the 12. And that gives us 19. And if we repeat that same procedure, that gives us all the remaining values of the arithmetic means. So doing so, we will have 26, 33, 40, 47, 54, 61, and to check, we may add another 7 with 61, and that gives us the other given 68. And now let us proceed with another problem. So here we need to find 4 arithmetic means between 1 and 16. So doing the same procedure, let us have our 1, and we need to provide 4 spaces for the arithmetic means, and finally we have the other given 16. And that brings the total terms to 6 terms. Having your 1 be a sub 1 and having the 16 be a sub 6. So with both of this information, we may now start solving for the common difference using the same formula. And for our a sub n, which will be a sub 6, whose value is 16. And for a sub 1, which is 1. Having your a sub n be a sub 6, this gives the n to be equal to 6. And now let us simplify the equation. So 6 minus 1 gives us 5, and the 5 times d gives us 5d. Now, we must apply your APE. So adding negative 1 to both sides of the equal sign, here we have 15. While this is equal to 0, writing only 5a. And applying the MPT for this equation, it gives us, anyway, so let me show you that we are multiplying 1 over 5 to both sides of the equal sign. So this gives us 3. So you may still apply your cancellation method for this, and that is by dividing the 15 by 5 like this, whose answer is 3. And 3 times 1 gives us 3. And now, so 5 divided by 5 is 1. We are only left with the common difference, whose value is 3. And using this value to reveal all the arithmetic means in the problem, so 1 plus 3 gives us 4, plus another 3, plus another 3, and plus another 3. Now to check, Adding another 3 gives us the other given 16. So the arithmetic means for this problem are 4, 7, 10, and 13. And let us have the next problem. So this problem is merely the same with the first two examples. And let us have this quickly. Insert 5 arithmetic means between 6 and negative 36. So starting with 6, providing 5 spaces. Okay? And writing the other given, negative 36. Having your first number as a sub 1, while the other given, so since we have a total of 7 terms, then negative 36 would be a sub 7. So you may have noticed that we can easily come up with these subscripts by looking at the problem this way, since we are given with 2 non-consecutive terms, and we are asked to insert 5 arithmetic means. So it gives us a total of 7. So having the first given be your a sub 1, and the other one will be a sub 7. And let us continue. So using our nth formula, and substituting all this information in the formula, we have negative 36 equals 6 plus, so remember that your n corresponds to 7, so we have 7 minus 1 equal times t. So let us simplify this equation first. So having this be equal to 6 times t, which is 60. Now, so we must eliminate or transfer the 6 to the other side of the equal sign by using APE. So for this purpose, we must add the negative 6 to both sides of the equal sign. Doing so, it gives us negative 42 equals 60. And for our multiplication property of equality, we must multiply the multiplicative inverse of 6, which happens to be 1 over 6, to both sides of the equal sign. So here we have a negative 7 equals 8. So for our common difference, we have the value of negative 7. So adding a negative 7 to 6, it gives us negative 1. Adding another negative 7 gives us negative 8. So we just have to continue doing this, and we have negative 15, negative 22, negative 29, and obviously, adding another negative 7 to negative 29 gives us negative 36.